Our today's class talks about the distance between 2 points on a globe, and I've been given here a question that reads, find the distance between the points A, 50 degrees south and 0 degrees east, and another point B, 70 degrees north and 0 degrees east. So we are told to express our answer in nautical miles and kilometers, taking pi as 22/7 and the radius of the earth to be 6,370 kilometers. So there are 2 points here. The first point is this, that is point A. And as far as this point is concerned, the coordinates in terms of the latitude and the longitude are 50 degrees south and 0 degrees east. There is another point B, that's point B, and the coordinates of this point in terms of its location on the globe or the Earth's surface is 70 degrees north and 0 degrees east. Now, for your information, any point on the globe has to have a latitude and a longitude. That is to tell you that unless otherwise, that points are lying on the equator or the prime meridian or the Greenwich meridian. Those points have to get well identified or located on the globe using their latitudes and their longitudes. For example, for me to locate a point A, which can simply mean a town on the globe, I'll have to actually move 50 degrees to the south and then move 0 degrees to the east. For me to locate point B, I'll move 70 degrees to the north and 0 degrees to the east. At the end of the day, I'll actually be able to have located these 2 points. Now, if you are told to get the distance between the 2 points, it's not a must for you to actually locate the points of the globe, but you can actually do that. So for my own way of actually teaching, to actually help you understand well what this means, we can actually just have a representation of our globe so that you can be able to locate those points here. So we shall have this, then you are going to have this as our equator, then have this as our prime meridian or our Greenwich meridian. So this is our equator, dividing the globe into 2 equal parts horizontally, and this is our prime meridian or Greenwich meridian, dividing the globe as well into 2 equal parts vertically. Now, we can have this as our latitudes. This can be our latitudes. This can be our latitudes. These are going to be our latitudes. Very good. Then we can have this as our longitudes. So we have both the latitudes and then the longitudes. This is our globe. So we have 50 degrees. So this is the northern part of the globe, the southern part of the globe, the western part, and the eastern part. As we proceed forward. So we have 50 degrees to the south. So as I move from the equator, which is always 0 degrees, the equator, this line, which has been darkened, I'm supposed to move to the south. So as I move to the south, I'm supposed to move 50 degrees to the south. So 10, 20, 30, so I can just have this as my 50 degrees to the south. 50 degrees to the south. 50 degrees to the south. Okay, this line here. So it's a latitude. Of course, the first value is always a latitude, and the second value is always a longitude. Again, this is our latitude, and this is our longitude. So our latitude is 50 degrees to the south. So you move from the equator, you go up to the 50 degrees to the south. This is our latitude, 50 degrees to the south. Then 0 degrees to the east. This is our prime meridian or our Greenwich meridian at 0 degrees, the center. So that point is found on the prime meridian. So towards the east, you don't move any degree. So that means the point lies on the prime meridian. This one. So this is the exact point where point A is located. 50 degrees to the south, and as far as our latitude is concerned, 50 degrees to the south, our latitude. Then as you move from the prime meridian towards the east, you move 0 degrees. That means you've not moved from the prime meridian. So this is the 0 degrees, okay? 0 degrees to the east. You've not moved any degrees to the east, so it's just 0. Then the 50 degrees to the south at the bottom, where they meet, can give us point A. That is point A. Okay, then we have 70 degrees to the north. So I go back to the equator and I'm moving to the northern part, 70 degrees. Let me have this as my 70 degrees. So maybe 10, 20, 30, 40, 50, 60, 70. So this can be my 70 degrees to the north. It's just as an estimation, so this cannot be as well be the most accurate way of actually representing these points. So let's have this as 70 degrees north. Okay, so 70 degrees north. So from the equator, you move 7 degrees to the north. Then again, 0 degrees to the east, our longitude. So from the prime meridian again, I don't move any degrees to the east. So again, the point is found on the prime meridian. So this can be point B. So if you actually look at this, these points are found on the same longitude, because lines moving from west to east are latitudes. Those moving from north to south are longitudes. So the 2 points are found on a longitude. So if the 2 points are found on a longitude, that must be a great circle. So if points are found on longitude or equator, either found on a longitude or equator, the points are found on what you call a great circle. So the longitudes and the equator are referred to as great circles. Then if points are found on a latitude or on latitudes, then they are actually found on small circles. That's correct. Now, our interest was to get the distance between points A and point B. Now, if the 2 points are found on a great circle, or a longitude for this matter, the prime meridian, and someone asks you to get the distance between them in nautical miles, distance in nautical miles. So the distance between the 2 points in nautical miles. What is the formula? You shall say distance is equal to, I think you can be able to see, so distance is equals to 60 times theta. That is the formula of getting the distance in nautical miles between 2 points lying on a longitude or lying on a great circle, or actually getting referred to as a great circle. So these 2 points are lying on a longitude, moving from north to south. They are found on a great circle. The distance between them in nautical miles is 60 theta. So I'll say 60 times. Then I come back here and look at these values. I have 50 degrees south and 70 degrees north. This 0 degrees, 0 degrees. This tells us that they are found on the same longitude. That's why I told you it's not even a must for you to actually represent them on the globe. You can just have a look at what the values are giving us. If the values are the same, that means as far as the longitudes are concerned, the points are found on a great circle. So that can just tell you. So 0 degrees east, 0 degrees east, they are found on the same longitude. So they form a great circle. You can just come up with the formula and then get the answer. So having known that, this is 50 south, 70 north. The two latitudes are not in the same hemisphere. They are in different hemispheres. To get the resultant theta, what do? We add those two values. So our theta is 120. I repeat, if it is 50 south and 70 north, the two values are found in different hemispheres. To get the theta, what do? We sum up their respective values or angles to get the theta. So that is 60 times 120. That gives us 7,200 nautical miles. That's the distance between the 2 points in nautical miles. Now, someone can ask you to get the distance in kilometers as well between the 2 points. What do you do? What do you do? The distance in kilometers will be worked out as follows. So you shall say D is equals to theta over 360 2 pi r. If the question asks us to get the distance in kilometers between the 2 points lying on a great circle or lying on the same longitude. So we shall have our theta, which is the same 120 degrees divided by 360 multiplied by 2 multiplied by 22/7 as the pi given multiplied by the radius of the earth, which is capital R, 6370. So that is theta 120/360 multiplied by 2 multiplied by pi 22/7 multiplied by R, the radius of the earth, capitalized as capital R, which is given as 6370. So let's pick our calculator and get the answer for this question. So we have 120 divided by 360 multiplied by 2 multiplied by 22/7 multiplied by 6,370. So that gives us 13,346.67 kilometers to 2 decimal places. So that's the distance between the 2 points in kilometers and as well in nautical miles. In some cases, you can find someone just converting from nautical miles to kilometers, which cannot be able to give us as well the most accurate answer, but can well be able to work well for us. We will always say that 1 nautical mile is equivalent to 1.853 kilometers. So we shall say, what about 7,200 nautical miles? You can as well do that. So what do? You just say 7,200 nautical miles, okay, multiply by 1.853 divided by 1, so that you can be able to get the answer for that. So let's see what you're going to get as our answer. So we have 7,200 multiply by 1.853. So we shall get 13,341.6. So almost closer to the answer we have actually gotten in this case here. So someone can do that, but unless the question asks you to do that, please use the formula to get the distance between the 2 points in kilometers. Thank you.